Welcome, everybody. I'm Alberto Ferrari. Tonight we're going to talk, well, tonight, it's today from your point of view. It's tonight here in Italy. We're going to talk about composite models over analysis services, the new kid in town in the analysis services scenario, in the Power BI scenario today. Nobody speaks about analysis services. Everybody is fond of Power BI. Just 10 seconds about who I am. I'm Alberto Ferrari. I work with Marco Russo at SQL BI. We do a lot of stuff related to analysis services and Power BI. We write books. The Definite Guide to DAX is likely to be the most comprehensive guide about the DAX language. And then we do training, consulting, and we have a lot of interesting titles. With that said, I'm not here to sell myself. We are going to talk about composite models in Power BI. Before we start talking about composite model, I think it's important to focus on one detail. Composite models are right now in preview mode. Preview means that they are not expected to work. So expect anything tonight. The version of Power BI I'm using, I installed it yesterday night. So it might work, it might not work. We have no clear picture. I will try to run the demo. If I was a Microsoft guy, I would probably know when it might break, but I am not. So anything can happen. In order to understand what composite models are and why there is so much hype about composite model, we first need to understand clearly what Power BI is, how it connects to the Power BI service, and what is the plus that composite model give you. And to do that, the easiest way is to start running a demo. I have already Power BI open here, and I'm just ready to open a connection with a data model that is in the cloud. So this composite model start is just a file containing the Contoso data model that I uploaded on the web a couple of hours ago. If I connect with Power BI to that model, what I'm creating is a live connection. Live connection means that the data is still in the cloud, and I'm using Power BI as a user interface. So I can build a report from here, take the brand and then the sales amount. Let me see if we do have sales amount. And let me increase the font a bit because I'm pretty sure that you cannot read anything, or at least I cannot read anything at my age. So right now I'm browsing the data. I'm looking at sales amount sliced by brand, but the data is still in the cloud and the entire processing is happening in the cloud. So I'm just using Power BI as a user interface to analyze the data. And that is very commonly used because it lets you create a report on top of a data model that somebody else has created and pushed on the cloud service. I can look at, I can build the report, I can look at the diagram, so I can look at the tables. I have sales, customer, product, and the date. These are the four tables. But I have a very limited experience if I want to change anything in the model. I can create a measure. So if I go here, I can go on sales, right-click, and you see I can create a new measure. I can create quick measures, but I cannot create columns, for example. I cannot load tables. I cannot create relationships. I have a very limited experience in terms of modeling. I can just compute new measures that are working on top of the data that still is in the cloud. And this is kind of a limited experience because if I want to do any kind of change to this data model, I have only two options. Either I start from scratch or I load the entire model from the cloud. I download a copy of it, and then I start working on a new copy of the model. But the two models will be always disconnected. So I just need to build a new branch of the same model. The reason why composite data models are so exciting is because composite data models give you the option of integrating new data in a model that still remains in the cloud. So by enabling composite data models, which is the official name, I guess, is DirectQuery over analysis services. We like to call them composite models. It's shorter. With composite models, I can extend the model so the data still remains in the cloud, but I will be able to add my own data to the model. So I build a model that is composed of two different islands. One is the island containing data that is in the cloud, and the other island is on my PC or on the model that I am creating. To enable composite data model, first of all, you need to enable it. Because right now, as I told you, it's in preview. So you need to go to options, and somewhere in the preview features, you have DirectQuery for Power BI dataset and analysis services. I call them composite data model. You need to enable that in order to be able to do the same stuff that I'm going to do. Now, this is still a live connection, so I cannot do anything, but there is this magic button here at the bottom, make changes to this model. It's enough to click on that to obtain a warning that tells you, hey, this PBIX has a live connection to a remote model. If you decide to turn it into a composite model, then you will enable DirectQuery, and this change is permanent. We're totally fine with that. We just click on add a local data model. And what is happening is that right now Power BI is changing the structure of my model. It will no longer be a live connection. It will be a DirectQuery connection. So I will have the local model that right now contains nothing, and the connection with the data in the cloud is now a DirectQuery connection. It's no longer a live connection. The difference is kind of important to understand the overall picture. When you are in live connection, what happens is that you are using Power BI as a user interface. So the query is completely executed by the remote server, the cloud service in our case. When you are working in DirectQuery, things are very different. You have two engines. One is the local one is the remote one, and the two work together. So part of the processing happens locally, part of the processing happens on the remote servers. And that is important, data need to go back and forth in order for the two engines to work. The engine is very smart. It tries to move most of the processing where the data is, but some measure, some calculation might require data to be moved back and forth. And because there is the network in the middle, this data movement might slow down everything. So nothing changed so far. I still see my brand, I still see my sales amount, but if you look at the option that I have now, if I go on sales, I no longer have only new measures, I can create new columns. That is, it was not available earlier. Now I can create a new column. For example, I can create a very simple column. Let's call it high sale, that just checks if sales quantity greater than 1, greater than 2, then we call it high sale, otherwise low sale. This is just a simple calculated column that contains two values that I created on the fly. Now the column is here. I can get rid of the brand, put the high sale column here, transform that into a matrix, and you see that I now see the amount for high sales and the amount for low sales. So what happened here? Did I really create a calculated column that is stored locally? Actually, not. That's not what happened. What happened is that the engine stored the information to tell to the remote engine that there is a new calculated column that the remote engine will compute, but is visible from the point of view of the user as if it was a regular calculated column. So you have the power of creating calculated columns that are not stored locally. They are still computed on the fly because that's a DirectQuery model, but the engine keeps track of all these changes. From the point of view of the user experience, you are basically creating just a calculated column, but this time it is not stored anywhere. And you can not only create calculated columns, that would be already cool, you can also load data. So you can, since we have two engines, the local engine and the remote engine, you can load data in the local engine and then mash up data with the remote engine. To do that, all you need to do is just go to get data. Let's say that we want to load data from an Excel file. I have an Excel file that contains some budget information. You can just open it. Let's say that I want the budget file. I can go for transform data and it works because this is Power Query running on my PC and it lets me mash up data. This table contains country, brand, and then 3 budgets. Let's get rid of low. No, I need, well, yes, let's do all the things the way they are designed. I don't want low, medium, and high as 3 columns. I prefer to unpivot the columns and call this a scenario and call this budget. So now I have China a datum scenario. I call this table budget. I just click close and apply. I need to wait until it refreshes. And here is a warning that is worth learning and understanding because it's important to understand what it means. Because now we have 2 engines, and as I told you at the beginning, data needs to flow from the 2 engines. The local engine will send the data to the remote engine, then the remote engine will send data back to the local engine. So there is an exchange of information that might contain information about your customers, information about your users, about your sales. It's really data that moves back and forth between the 2 engines. So you need to be aware of that. And this is exactly what this security risk is warning you of. We are not worried about that just because this is Contoso, but you need to take that into account. So now I have this new table, budget, here. And it's interesting to see that I can look at the data of the budget table. If you look here, I have the same values that were previously in the Excel file. Now they are stored in the local model and they are here. This is the only table I can look at. If I look at customer, it says, hey, this table uses DirectQuery. No way you can look at that because the data about this table is in the cloud, so you do not have access to it. You know the structure, but you don't see the data. Whereas the budget table, this table is here in the local model, and you can look at that and you can add columns and do all the usual operations. Keep in mind, because that is important, the budget table loaded from Excel is in the local model. The sales table is still in the cloud. We didn't move the data back from the cloud. Now we can get rid from here of the column we created. We put again the product brand, and you see that brand is slicing sales amount. Brand is one of the column of the product table. It works, so I'm slicing sales amount, but if I take the budget and I drop it here, it doesn't work really well. It shows the value of the budget, the same value everywhere. And the reason is budget is here, product is here. There is no relationship linking the two tables. So a filter on product does not reach budget in any way. Budget has its own column. For example, there is the scenario column that I can use with a slicer. Thank you. Let me increase the font of these two. See that if I change a column in the budget table, the values change, but the brand is not filtering. The thing is, it's true that the budget is local and product is remote, but one of the cool features about composite models is that I can build relationships between tables no matter where they are. So I can take the brand, drop it here, and I obtain a warning because brand is neither a key in product nor a key in budget. So the relationship will be a many-to-many relationship. I don't want cross-filter direction to be bidirectional. I want product to filter budget. I click on OK. And now what I did, I created a relationship between the product table, the cloud, and the budget table, local. If I now look at the report, you see that I have my sales amount, which is not formatted correctly. So let me fix that. Sales amount, I want you with decimal number. Okay, I have the sales amount and the value of the budget together, sliced by the brand. If I look back at my table, I have the budget, and I also have the country region, which is in customer. So we can move data here and there. And we take the country region and do the same operation. And that's a one-to-many, many-to-many customer filters budget. Okay. Now we have two relationships, one with customer and one with budget. And the net result is that I can slice by brand or I can slice by country region, and everything is just working. If I go here, I look at customer, take the country region, move it here. I see the budget for China, Germany, and United States, and the sales amount for Germany, China, Germany, and United States. Now, it's interesting to understand how it is working because my goal is not to show you a demo where at the end you say, whoa, I want to use composite model tomorrow. My goal is to let you understand when it makes sense to use them, and most important, in my opinion, when it does not make sense to use them. Because if you think at how this query needs to be executed, the country region is a column in the remote table. Country region belongs to customer. Customer stays in the cloud. Budget is a column which is local. So there are two possible options. Either we run a query against the server that retrieves information about the country region, and then we use the values that we obtain from the server to filter the local table. Then we run another query on the server to obtain this part of the query, country region and sales amount, and we run a local query that retrieves country region and budget value. And finally, we mash up everything. This is likely to be exactly what is happening. But you need to understand that there are these two steps, and the list of country regions needs to go back and forth between the local server and the remote server. The filter on the scenario is not sent to the cloud because scenario only affects the budget, but the country region needs to come back with the sales amount and with the values in order to filter the budget value. Whenever you are curious or whenever you want to understand how data is moving back and forth, what you need to do is just enable the performance analyzer, start recording, refresh the visual, and this shows you the DAX query that has been executed. If you copy the query and open DAX Studio, you have the option of inspecting the query and understanding what happened. In order to understand not only the data that went back and forth, but most relevant, where's my DAX Studio here, the amount of data that goes back and forth. You see, this is the query executed that places a filter on the scenario and then groups by customer country region and computes sales amount and the sum of budget value. You do not see the remote queries. This is a query that is only executed by the local engine. But if you enable server timings and then you run the query, under server timings, once the query has finished, okay, you can look at the individual queries executed by the server. This is a vertical query. This is a DAX query. You can copy everything, put that into a new window, and this is a query executed by the server, so the cloud service that retrieves by country region only the country region which are referenced in the customer. So this is basically only retrieving the values of the country region. And then we have another query that retrieves only the sales amount. Okay, and this is the query that retrieves the value of the sales amount and the customer. Again, this is executed by the server and retrieves the customer country region and then the sales amount for each country region. So you see that there are two queries, one executed by the local engine, one executed by the remote engine. In this specific scenario, everything works fine because the engine has been able to run the best query on the local server and move a small amount of data back and forth to the remote server. Things can be much more complicated if the code that you author is, of course, more complicated, more intricate. So we have seen that you can create calculated. Oh, we haven't seen the calculated column. While we are here, it's worth looking also at how calculated columns are generated. So let me get rid from here of the budget value, the country region. We still have the calculated column, high sales. Let's drop it here. High sales here, high sales here. Get rid. Okay. We can grab the query that has been executed to filter the calculated column. And you see that this is the query executed by the local engine that contains our usual calculation. We run it. No, I need to run it from here because I want to grab the query executed. And you see that this is grouping by the calculated column sales, high sales, but the query executed by the server is here contains the define column statement. It's define column sales, high sales that contains the code of the calculated column. So this is important because you see that the calculated column is not stored in the local engine. The calculated column is sent to the remote engine, computed on the remote engine, and the result of the calculated column is then used by the local engine to perform the last operation of grouping by or potentially joining with other tables. And you always need to take into account these two steps. You have one part executed on the server, one part which is executed locally. Why this is important? Because this query can be very small, like in these cases. If you look at this query, it's very small and the result contains just a couple of lines. But in other scenario, in other more complex scenario, these queries start to be very large and they slow down the entire experience of users. This is not what you want. So do not expect that you will be able to do with composite models everything that you are able to do with the Vertipack model or with a local model, because there is this strong limitation of data going back and forth that requires you to restrict at a minimum the amount of information exchanged between the two servers. If that amount is too large, then experience will be really, really bad. Let me show you another example, because so far we have done simple things. We created a budget table, we built a relationship. Actually, we call it simple. It is not. If you think of the technology that is needed in order to make all this work, we're building a relationship between tables that are stored on different machines in different parts of the world. So this is totally not a simple thing, but it's not that complicated. The scenario where I expect the most usage for composite models is when you have a large model. You have users that want to increase the power or do further analysis. For example, I might want to do the analysis of customer categories. So I have customers, I have the sales amount. Let me get rid of high sales and take some column of the customer. So for example, country region is the customer. It is taking a bit too much time. It is taking a bit too much time. So as I anticipated, it's also likely that I'm crashing Power BI. Let's count up to 10 and let's get rid of everything. No, it's still there circling. So what we Let's try to open a new connection and see if I can revive it. Otherwise, we will need to start and rebuild the model. Looks like a new visual works. Let's build the matrix. Let's add sales amount. Yeah, we are safe. I have the country region and I have the sales amount. What I might want to do is cluster my customers into different categories. So I want to create a high category, low category, medium category, and then cluster my customers, count how many customers I have in different categories, and then look at the sales amount of the different categories and so on. To do that, what I need is a table that lets me cluster the customers, and I don't have such a table in the model, but I can create a calculated table. Now, I'm not going to type the code of this calculated table. I only need to find where I already put the code, but I want to show you the kind of complexity that you can reach. Let me create a new table, paste the code, and then I will comment it a bit so we can understand what it does. I'm scared of this work. No, it worked. Okay. What does this code do? Well, this code creates categories of customers, but I wanted, since I'm a lazy guy, I wanted to build a calculated table that creates the clusters automatically. So I say I want 6 clusters. Each cluster needs to contain a given percentage of customers, that is 1 divided by the number of customers. Then I retrieve for each customer the sales amount, and then I create a table that contains numbers from 1 to the number of clusters, that contains the cluster number, and then the minimum amount of sales. And finally, I compute the maximum amount of sales, and I define the 2 boundaries of each cluster in an automatic way. The result of this table is visible. I can inspect it because I can inspect it. I can see it here. It generates a table that says, well, cluster 1 needs to contain the customers whose sales amount is between this value and this value. These are the 2 values that define the boundaries of the cluster. Right now, they do not look very readable because we are using a generic format, but if we use decimal number for both, it will be much easier to look at the values. So you see that I have the boundaries. Mean sales is here. Max sales is always the next mean sales or the maximum amount of sales. And now that I have this column, I can use it to create measures that work on top of my model. The important detail that I think is worth mentioning here is that if you carefully look at this code, you will see that this code actually mixes information coming from the remote server, and it might mix information coming from the local server. This table is so complex that the engine will decide to store it locally. And again, that is an important concept to remember. You might have tables or columns that are calculated tables or calculated columns, but the engine, for optimization purposes, might decide to send the calculation to the remote server every time it needs to compute it. What happened earlier with the high sales column? The high sales column has not been computed locally. It is sent to the server every time it is needed because it's faster to obtain it that way. But a table like this one, that is too complex. If I try to send the code of this table every time I need to retrieve values, that will take forever. Therefore, the engine will probably decide to compute this table and store it locally. The experience is going to be very different. First, we need to prove that. Let's get rid of the country region from here. So, okay, let's get rid of country region, sales amount, and we replace it with the cluster name, the minimum and maximum sales. So I have the name, the minimum, and the maximum sales that need to be uh, that is the amount for a customer in order to show it. First of all, which engine will execute this query? We know how to check it. We just go to View, Performance Analyzer, Start Recording, refresh the visual, copy the query, and then with Tag Studio, we look at the content of the query. We have a summarized column that groups by customer name and computes minimum and maximum sales. I always forget to do that in the right window. That is this one. Run the query, and you see that the query that is executed, this is a regular XM SQL query. So this query has been executed locally, it has not been sent to the server. The code of the calculated table is so complex that the engine preferred to materialize the table locally and execute the selection of values locally. So now we have a calculated table that grabs data from the remote server, but it is stored locally. I guess you are starting to see the complexity of the models that you generate. Data can be stored anywhere, and when you run a query, the engine decides from where to grab the information. So the table is here, but so far it's useless because I'm just looking at name, minimum, and maximum sales. How can I compute, for example, the number of customers that belong to each different cluster? That we can compute together. We can build a new measure. And yeah, we can write that. Let's call it customers in a cluster. I can make it simple, like count rows. I count the number of customer where the sales amount is greater or equal. I need the minimum value of the customer, so var is storing a variable the lower boundary, which is the minimum value of the segments. How did I call it? Sales cluster. Sales cluster minimum sales. I want the upper boundary, which is the maximum of sales cluster. And then I count all the customers whose sales amount is greater than the lower boundary and where the sales amount is less, strictly greater, less or equal the upper boundary. And that computes the correct number. You can find this pattern in a lot of places, like at SQL BI. But I'm not going to put it in the matrix. The reason why, actually, I can put that into the matrix, but we will not look at the code. If I drop the measure here, first of all, it's worth to note that it's not fast, not at all. If I don't remember bad, this takes around 25, 30 seconds to run, which is totally crazy. Don't know how much it took, but quite a lot of time. This is the number of customers in each cluster. This is the total number of customer. The separation is nearly the same everywhere because of the way we build the cluster. The cluster are designed to hold an equal number of customers into each, separating them by the sales amount they produce. But you have seen that performance is really bad. And this time, I'm not going to show you the code because it would take forever just to look at the code. The query that is generated is just huge. Why that? Again, we need to think at how the engine can solve this query. The query is built on top of different parts. First, we retrieve the minimum sales cluster minimum sales and which part of the engine will execute that. We already know that sales clusters is stored locally. So the minimum value of a column that is stored locally is computed locally. The maximum value is computed again locally. So these two variables are computed locally. But what about this? Here I'm mixing a query that contains a filter over the customer table. For each customer, I need the sales amount, and I need to check that its value is between the lower and the upper boundary. There are a lot of ways you can run this query, but unfortunately, the way that the engine chooses is to move the entire customer table back and forth between the local engine and the remote engine. It's definitely bad. It's a no full query plan, but it is exactly what it does. So this query takes a lot of time because I'm referencing the customer table. If I want to make it faster, instead of using customer, it's enough to use customer key. So to reduce the number of columns that is being iterated, and this is already a bit faster. You can look at here, it's a bit faster than earlier. Before it took around 20 seconds, now in 2-3 seconds it runs. But still, it's not the best option. It takes some time to run. And before we move further, it's important that we focus on one detail. If you want to efficiently use a composite model, you need to be able to do the same stuff that I'm doing right now. That is, express a query in different ways and understand how the engine is going to solve the query. Because the kind of problems, the performance issues that we are having now, you will never see them if you're just using an import mode, a regular mode that runs in import mode. The problem here is not the DAX engine, it's the transfer of data. You need to reduce that at the minimum. Anyway, now performance are not that bad, and we can inspect this query to understand what is happening. So we can again open the performance analyzer, start recording, refresh the visual. So we have a first baseline to see how long it took. It's not that slow, it only takes 3 seconds. Now we can copy the query and look at the time it took. Between the click and when the arrow came out, a couple of seconds passed because the code is quite large. Then we open DAX Studio, we go here, paste the query, so we look at that. And you see that the query is not very complex. It computes by cluster name, the sum of the minimum and maximum sales, and then the number of customers in cluster. The problem happens if I run the query, which I'm doing right now. It will take 2-3 seconds to run, but we will be able to look at the content of the query executed. The first query only retrieves minimum values. The second query retrieves the customer key. And look at that. This retrieves for each customer its customer key. So this query is executed on the remote server, and from the remote servers, it grabs the entire set of customer keys. If you have 1 million rows in customers, 1 million rows need to go back and forth. Then we compute the sales amount by customer key. And here it is. This is the query which is the most important one. This query is basically sending in plain text as another query the full list of all the customer keys. So the customer keys had to be evaluated on the server, sent back to the local machine, and then from the local machine sent back to the server again to execute another query. It's very inefficient to write code this way. If you plan to use composite models, you need to worry about these details, and you need to write code that runs in an efficient way. How can we make this faster? Sorry. Let's get rid of that. Let's go to customers in cluster. This is the version we obtained so far. We can actually write the code in a simpler way, not a simpler way, but in a different way. If we create another variable that I call customers and sales, where I just create a variable containing all sales customer key and a column amount that contains the sales amount. And finally, instead of counting this filter, I filter the content of the variable customers and sales. Let's put that into a variable result. Let's call it customers in bucket. Use this filter, and then I return count rows of customers in bucket. Now, what is the difference between this code and the one that I wrote previously? If you pay attention to that, I'm trying to separate the processing that need to be executed on the local machine from the processing that need to be executed on the remote machine, so that the different steps of the query will be executed by different part of the engine, trying to reduce at a minimum the amount of data that need to go back and forth. My hope is that this part of the query only uses columns and information that are on the remote server. So I do not want I do not need, I need the result, but I do not need to inject information here. And once I have the result of this query, the second part of the query only uses, that's wrong, only uses information from that has been already retrieved. So I do not use sales amount that would trigger context transition. Instead, I use just the amount column. My hope, and to be honest, it's more a hope than anything else, is that this is going to be much faster. The numbers are still the same, but we need to look at the performance analyzer to look at that. I lost it, performance analyzer, start recording, refresh the visual, and it was around 3 seconds. Now it's much faster. We can copy the query, look at the DAX code generated, paste it into DAX Studio, run the query. It's probably, no, it might crash. And look at the code. We have the first part that retrieves minimum and maximum sales from my calculated table. Then we retrieve the values of the customer key. We summarize sales by customer key, and we select values from the table. You see that the gigantic query containing all the customer keys being sent back and forth disappeared. So, does all that mean that if you plan to use composite models, you need to write code thinking about the problem that that code will be executed in a composite model? Unfortunately, the answer is yes, you will. You need to know where the data is, and you need to write code in such a way that the amount of data moved back and forth between the two engines is reduced to a minimum. If you do not do that, then unfortunately performance will not be good. Composite models are not designed to let you build any kind of relationship, build any kind of calculated column or any kind of measures without thinking about what you are doing, because somebody might be selling you the idea that with composite models you will be able to merge models the way you like, but the sad truth is that this is not the case. Composite models are an extremely powerful tool that really lets you join tables that are stored on different machines, on different architectures, in different places of the planet. But Along with this increased power, you also have the responsibility of writing code in such a way that performance will be good. If performance will be bad, the problem is you are using composite model for to obtain a goal that is not what composite model were designed for. So what I think about composite model is that they are a beautiful tool, a very powerful tool, but it needs to be used with a lot of care. If you do not pay attention to the code and to the architecture you are building, then you will have a really bad experience. There are other considerations that are worth doing, and they are all tied to the same topic that we are covering. We have in this model, right now we have a sales cluster. This is a local table. Then we have product, sales, date, customer, and budget. These are all remote tables. And data is mashed up between the local table and the remote table. Now, if you have some experience in data modeling and in database design, you know that when the same data is stored in two different places, you have a serious problem in keeping the data in sync, keeping the data synchronized. What happens if a new product appears here or new sales are stored in this table? Does the sales customer table, which is worth remembering, sales clusters depends from sales amount. So as soon as new sales appear, theoretically, this calculated table should be recomputed. The thing is, Power BI is not going to do that by itself. Power BI computes this table when you hit refresh. If I click refresh, which I'm not going to do now because I'm scared that it might crash, but if you hit refresh, the calculated table will be recomputed and the Excel file will be reloaded and the local data storage will be rebuilt. But until you do that, you will have no automatic refresh. So the data from the cloud and the data in this calculated table might be out of sync as soon as this model is refreshed. And it's up to you as a developer to make sure that data is kept in sync. Things can be even harder than that because nothing prevents you from going one step farther. And I'm pretty sure somebody is thinking about that. I have part of the model, this part which is in the cloud in Power BI Premium. Part, actually Power BI, whatever. Part of the model, this sales cluster and this budget table, these two tables are in the local model. But is anything that is preventing me from connecting this model with another data island? The answer is no. You are free to do whatever you want. I could create a connection with DirectQuery on top of SQL Server to a SQL Server database to have real-time data that is updated in real time. But this again raises the problem of having a composite model that has three different data sources that might be very easily out of sync. And it's a serious problem that you need to worry about when you think about using and implementing composite models. You need to think about all these topics, all these details. In my opinion, the most relevant things you need to worry about are first, performance. The data, the amount of data that goes back and forth between the two engines need to be reduced at a minimum. Second, data consistency. The data need to be refreshed consistently in such a way that whenever you run a query, you always have correct information. And number of islands. If you have a lot of data islands, meaning many data sources, each with its own data set, then very quickly you will have problems because data will not be in sync the correct way. So what is, in my opinion, the correct usage of composite models? What I think is that composite models work beautifully if you plan to have a large corporate data model in the cloud, and you extend it with small tables, and you pay attention to the details of writing code the right way. I'm pretty sure that right now, while we are talking, there is somebody in a meeting room that is discussing about, hey, now that we have composite models, we will be able to build like 10 different corporate models, and then the users will be able to mash up everything using composite models. That's going to be a nightmare because the amount of data that need to be moved back and forth between all these engines every time you run a query is going to kill the performance of whatever server you have. So this is a bad usage of a composite model. Think about composite model as a new tool that helps you working with your data and helps the power user to work in an efficient way. Furthermore, and that is the last thing that I want to tell you before I leave some space for Q&A, if you have any, and I already forgot what I was about to say. Oh no, yes, the last thing is uh, why I did the session this way. This was an introductory session, and I show you DAX Studio. I show you the Vertipack analyzer, not the Vertipack analyzer, but I've shown you DAX code and quite complex DAX code. The reason was not to scare you, or the reason was to scare you a bit. Uh, I think composite models are extremely powerful, but I want to send a gigantic warning to every user that is before using composite model, make sure that you have the knowledge needed to use them properly. I'm not used to sell my training at any time, but really, if you plan to use composite models and if you want to use them in an efficient way, spend time learning not only DAX, this is the first prerequisite, but also how to optimize DAX and how to read the query plans and how to understand how the DAX engine works. Because you will have a tremendous weapon in your hands. You will be able to build really powerful models, but you will need to do them properly. So the moment when to start learning how to optimize code, how to optimize that code was not yesterday. Yesterday, you could live a happy life without knowing the details about the engine. Tomorrow, when we will have composite models, you will already need to know that. Today, the best thing that you can do is spend some time learning how to optimize code. We have videos which are available for free on the web. We have books, we have training, we have a lot of ways that we can help you in learning that. But do that. Don't waste your time, because if you do not know how to optimize your code, you will probably be in trouble much sooner than you expect as soon as you start using composite models. And as you have seen, this is not a marketing session at all. My goal was not that of selling you a composite model. My goal was to show you what you can do without too many bells and whistles and the problems that you might face as soon as you start using them.